All right, now that we know what sine, cosine, and tangent are, and we can use them to find side lengths, now what we can do is we can talk about the inverse of sine, cosine, and tangent to find angle measures. So just so we remember, it's SOHCAHTOA. So we have that in mind because no matter what we do with our sine, cosine, and tangent, we still want to have the correct ratio, okay? But let's just remember, what if I want, let's just look at example 1 and let's see if with the information I have right here, cosine A equals 24 over 25. What if I want to find which one is angle A? How do I do that? Because today we're going to be focusing on how to find the angle, right? Is angle 1 or angle 2 A? So what we can do is we can, of course, just figure out the ratios. So if I'm looking at cosine, I'm looking at CAH. So I can basically say, well, cosine of angle 1 is adjacent over hypotenuse, right? So I'm going to pick the right adjacent, so that's 1.4. Hypotenuse is 5. And then I want to reduce that and see if that's going to equal, and see if that equals 24 over 25. Remember, I can move that decimal point over to get 14 over 50, and that is 7 over 25, which is, nope, not angle 1. So obviously it should be angle 2, but let's just double check. So cosine of 2 is, again, hypotenuse doesn't change, but now adjacent is 4.8. Right? So that's going to be 4.8 over 5. And that's going to give me 48 over 50, which does reduce down to 24 over 25. So angle A is angle 2. So you can see how we can use the ratio to determine angles in a triangle, obviously using the ratios. But what if I wanted to know the measure of angle A? So I know angle A is angle 2, but what is that in degrees? Well, what we want to do is we want to use what we call the inverse of sine, cosine, and tangent to figure out those numbers. So let's go ahead and jot this down. So those are what we call our inverse trig functions. Again, feel free to pause if you need to as you jot this down. So you'll see the notation is sine, and it looks like an exponent -1, but what this means is it's the inverse. So just like how plus and minus are inverse operations, sine and the sine -1 are a pair of inverse operations. So remember, sine is an operation. And the same is true for cosine and inverse cosine, tangent and inverse tangent. So when you say this, if you say sine -1, I'll know what you're saying, but that's not technically right. We would say this is the inverse of sine, right? Or the inverse sine of x, okay? So again, this helps you find the angle measure. So I can just basically take the sine and move it to the other side. I'd find that angle measure. But I can't just divide by sine or divide by cosine, divide by tangent to get A by itself, but I have to use that inverse operation. Okay, and that's a button on your calculator, which we'll be looking at. So just one quick example here. If we wanted to find what angle A was in the example, then I would again be using that inverse cosine. So cosine of angle A was equal to 24 over 25, right? And that 24 over 25 is 0.96. And you can feel free to use the exact decimal, not rounded, or the fraction the way it is. So I'm going to just write that as 0.96. That's the exact decimal. And remember, I can't divide by cosine, but what I can do is I can say, well, the measure of angle A would equal the inverse of cosine, the inverse cosine of 0.96. Okay, and this is what we call the exact answer, and this would be what you put into your calculator. And a lot of times you're going to have to put the second or the shift button and then hit cosine, and that'll get you the inverse cosine. But then that should give you the measure of angle A is approximately, let's round this to the nearest degree, should be 16. So if you don't get 16 when you're trying this out in your calculator, make sure you make a note of that and ask me in class tomorrow so I can tell you how to do those inverse functions before your quiz. All right. Taking a look at example 2, we want to find the unknown measures, round the lengths to the nearest hundredths, and angle measures to the nearest degrees. And here you're going to have to make sure you read the directions carefully. I want everything that's unknown, so all angles and all sides. And you don't have to use trig for all of these. So you can, for example, look at this, and I have 5 and 5.7. I'm just missing st. Well, I can use my Pythagorean theorem here. But again, it's kind of up to you and what you feel the most comfortable with doing. Okay? But let me go ahead and label what I'm missing. So I'm missing the side st, I'm missing angle t, and I'm missing angle r. So I just went ahead and called it x, y, and z, so I know for myself what I'm missing. But for these types of problems, you have to go through and see what is it you need to find. Okay, make sure you're rounding lengths to the nearest hundredth, right, and angles to the nearest degree. So reading all the way through. And again, it's up to you and how you want to find this stuff. I would personally do Pythagorean theorem to find st, because x squared plus 5 squared is equal to 5.7 squared. So I didn't have to do sine, cosine, or tangent for that. However, you could once you find one of the angles, y or z. It's kind of up to you. All right, so going ahead and doing this, I get x squared plus 25 is equal to 32.49. So x squared is equal to 7.49. Square rooting both sides. Remember, it's a length here, so I only want the positive answer. And I want to round that to the nearest hundredth. So I'm going to get 2.74 as my missing length. So this is st. Okay. Then to find the angles, well, this is harder. I can't just assume it's 45, 45, 90. And clearly it's not isosceles because the x is 2.74. So here's where I have to throw in my trig. So it's up to you and what you want to find first. So for example, I'm going to use y. Then I'm anchoring myself at y. And then I want to see, well, what's given to me. So 5.7 is a hypotenuse no matter what. And 5 from the y is the opposite. So to find y, I'm going to do opposite over hypotenuse. So that is sine. So you want to take a look at what you're given, right? Opposite and hypotenuse tells me I've got sine. So once again, go back to SOHCAHTOA. So sine of whatever y is going to equal to 5 over 5.7, right? And I need to do my inverse operation. So I'm not dividing by sine because that's going to give me an error in the calculator, but y is going to equal the inverse sine of 5 over 5.7. And you want to do this in your calculator. Let me make that 7 a little bit easier to read. 5.7, there we go. So for some of you, you're going to have to do the 5 divided by 5.7 first. Some of your calculators can handle it all the way through. It's kind of up to your calculator and how it was designed. So what you want to look for is you want to look for that inverse sine button, and then whatever you get for 5 divided by 5.7, throw it in there. Remember, don't round. All right, don't take that 5 over 5.7 and round it to the nearest 1 or nearest 10th, but use the exact number in your calculator. So let me show you what I would do in my calculator. So I would take that 5 divided by 5.7 exactly the way it is. So you'll see in your calculator it's 0.87719 298, etc., etc., etc. I'm going to keep that exact number in my calculator, and then I hit my second button and sine, and the answer is approximately 61 degrees. All right, and that should be angle T, right? So that is the measure of angle T. Now what you can do is you can go ahead and use the 5 and the 5.7 with the z now, using 5 as your adjacent and using cosine to double check. But if you're really, really confident this is the right answer, remember 3 angles in a triangle add up to what number? Hopefully remember that's 180. So 90 plus 61 plus z should add up to 180. So doing that math, I should get z equals 29 degrees. And again, you can double check this. This is measure of angle r. Check using cosine. So just do a quick check. Is when you see cosine of 29 in your calculator, that's about 0.874619, et cetera, et cetera, et cetera. Is that equal to 5 divided by 5.7? And yeah, it looks good to me. It's close, not exact because we rounded, but it's pretty close, so it looks pretty good. But again, you can always do the inverse cosine to double check as well. Okay. Example 3. So let's look at this triangle here. PQR, we want